This multi-agent system just processes 100 internal documents, 0 API calls, $0, completely offline. Building agents in the cloud is easy until enterprise privacy rules block you. You know that feeling. You try to push your workflow and security says your data can't leave the network. Today we built a private multi-agent setup to bypass the cloud entirely. So we wire LangGraph directly to Llama. Instead of passing API keys, your local models handle the routing and tool execution. And the cool part is you don't lose any framework capabilities just because you operate offline. This setup gives you full control over privacy without sacrificing agent logic. Alright, there are two main pieces to this architecture. First, we spin up the local Llama instance as our LLM backend. Then we build a LangGraph state machine to orchestrate the actual agents. And notice that everything stays securely inside your firewall. That is all you need to know before we start. Enough theory, let's build it. Now let's get the environment set up. We need LangGraph for the state machine, LangChain, and the standalone Llama package. Before writing code, we need a model that actually supports tool calling. Standard Llama 3 doesn't handle this well. We will pull Llama 3.1 instead. It's optimized for exactly this kind of agentic workflow. Now inside the local agent.py file, we specify all our imports up front so we don't have to jump around later. Then we set up our LLM and state memory. Notice the temperature is set to 0. We want predictable routing decisions and not creative writing. That messages annotation tells LangGraph to append new messages instead of overwriting history. Now let's give the agent something to do. We built a simple tool that processes internal documents completely offline. The key detail here is the docstring. The local model uses it to figure out when to trigger the tool. And finally, we bind it to the LLM. And now let's build the main agent node. This function passes the message history to the model and returns the updated state. What is actually happening here is the model reads the context and decides whether to reply or request a tool. We need a way to decide where the graph goes after the agent speaks. This function checks the very last message in the state. If the model decided to call a tool, we return a signal to continue. Otherwise, we end the workflow. This simple check prevents infinite loops. This is where the entire architecture comes together. We initialize the graph and drop in our nodes. Notice the conditional edges. If the router says continue, we hit the tool node and loop right back to the agent. If it says end, execution stops entirely. Now it's time to verify the whole system. We feed it a prompt asking to process a document. Now let's run the script from our terminal. If Llama is working correctly, you should see the agent thinking, then triggering the node and finishing the job. And just like that, you just executed a completely private workflow. Alright, let's look at what you have actually got running. You now have a fully functioning multi-agent system operating completely offline. Your sensitive enterprise data doesn't leave your machine. You don't have to worry about API costs scaling out of control. And you still get complex routing and tool usage. Next step, try swapping out the base model. Pull a different open source model into Llama and see how it changes the agent behavior. And if you're building real AI applications and want more tutorials like this, hit subscribe. I'll catch you in the next one.